Disc brake service is more than installing new brake pads. The brake rotor must be visually inspected for scoring and hotspot damage, and then measured to determine if it is above minimum thickness specifications and runout. Visually inspect the rotor for damage, including damage from metal to metal brake pad contact, overheating, brake pad material transfer to the rotor surface. Measure the brake rotor for thickness to verify it is above minimum thickness specifications. A brake rotor vernier caliper can be used for this, as it has measuring jaw tips that allow for measuring the rotor thickness without interference from the raised edge that can occur at the outer edge from normal operation. Check at 6 to 8 places around the rotor, midpoint between the outer and inner brake pad contact area. Differences in readings indicate thickness variation. Use the smallest reading and compare with the minimum thickness specification in the service information. A rotor that is below minimum specifications must be replaced. A rotor that is very close to minimum should be replaced, as it will most likely be below minimum specifications after machining the surface. Brake rotor thickness can also be measured with a micrometer. Micrometers are more accurate than vernier calipers. Measure at 6 to 8 locations around the rotor at the midpoint of the pad surface area. A digital micrometer provides an easy-to-interpret reading. Here's how to read a standard type micrometer. The sleeve number indicates how many tenths of an inch. Here it is 5, which indicates 0.5 of an inch. The thimble lines up with a line on the sleeve. Here the closest line indicates 0.075 of an inch. Locate the line on the thimble that lines up with the sleeve scale. Here it is 7, which indicates 0.007 of an inch. Add the readings together to obtain 0.577 of an inch. Brake rotor runout is a critical measurement that determines how much the rotor surface moves inward and outward during rotation. Excessive runout causes vibration during braking. Runout is measured using a dial indicator. Set up the dial indicator as follows. Secure the rotor to the hub using washers and lug nuts. Clamp the locking pliers to the steering knuckle, strut, or other suspension component. Place the dial indicator needle about 1/2 inch in from the outer edge of the rotor. Apply very light pressure on the dial indicator housing to center the measuring needle about halfway between in and out. Then lock the flex joint to hold it in place. Set the dial indicator to 0. Slowly turn the rotor by hand and measure the highest and lowest reading indicated. Add those readings together to obtain total runout. Compare your readings to specifications. Most manufacturers specify runout must be less than 0.003 0.003 of an inch. Most manufacturers require the use of an on-vehicle brake rotor machining. This helps eliminate runout issues related to hub and rotor surface mating variations, since the rotor is machined while mounted on the hub. Follow the setup procedures for the on-vehicle brake lathe used at your shop. During machining, it is important that vibration of the cutting bits be minimized. Use brake machining silencer tools to eliminate this condition. Vibrating cutting bits will create grooves in the rotor surface that can cause a variety of brake issues, including brake pad squeal and poor brake performance. Off-brake rotor machining is done with a brake lathe as follows. Remove the rotor from the vehicle and follow the brake lathe adapters to mount the rotor on the machine. Install a silencer band around the outer edge of the rotor to prevent cutting bit vibration noise during machining. Adjust the cutting bits outward and then move the cutting assembly inward to align the bits with the inward edge of the rotor surface. Adjust the cutting bits to remove the desired amount of material and then start the cutting bit process. After rotor machining, most manufacturers recommend using a scuff pad on a low-speed drill to prep the surface for brake pad seating to the rotor surface. It is also good practice to clean the rotor with brake clean solution or spray to remove any oil residue that may be on the pad contact area of the rotor.